So page 2 of exam 2, they give us this function right here, and they want us to factor it into linear factors, and they tell us one of the zeros. Well, if you know a zero, then you know a factor. So remember, if c is a zero, then x minus c is a factor. Okay, so that's what we're looking at here. So since we know a zero, we can go -4. And we're going to divide synthetically. 1 minus 1 minus 14, 24. Now we know it's supposed to come out to be 0 because we were told -4 is a 0. So bring down the 1, multiply, add, multiply, add, -24, and sure enough, that's a 0. Now, that means that when we think about the factors, x minus a -4, so I'm just note to self, x minus a -4 is going to be one of the factors because -4 is a 0. So sometimes that part's confusing. But the other thing is, now that our original was an x cubed, so now we're down to an x squared. So that's 1x squared minus 5x plus 6, and we want to factor that. Well, we can factor that. It factors into x minus 2 and x minus 3. Now I know that's tricky because of the 6. It could have been 6 and 1, but it's not. It couldn't be 6 and 1. Anyway, they both had to be negative, and -2 and -3 make -5. But here's the thing. What's the answer? They wanted the function written, factored into linear factors, and you have them all. You have the one that we did up there, which winds up being x plus 4, right? So this right here is x plus 4. That's one of the factors. There should be 3 linear factors. So that's one of them. And then the other 2 are x minus 2 and x minus 3. And I say there are 3 linear factors. That's if there are 3 real solutions. So anyway, well, you can write, I'm going to skip over that part. Okay, but there's the 3 linear factors. You're going to see what I'm talking about, what I'm skipping over here in the next problem. Okay. Find all the zeros of the function, and we're given 1 0, 2 minus 3i. Okay, so if you know a 0, let's just put that in there. 2 minus 3i. And then we're pulling off these coefficients. 1, -7, 25, and -39. Probably shouldn't have taken quite so much room. Because of the I, because it's not a real number that our 0 is, it's going to take us a little more room. But 1, bring down the 1, multiply, that's 2 minus 3i. Now sometimes people didn't know what to do with that, but you're combining the real parts. So that's a -5 minus 3i. That's it's a little tricky. So how can I write this so you can see it? I'm going to multiply, right? So over here, I'm going to say 2 minus 3i times -5 minus 3i. Now, I don't know what that's going to be, but I'm going to figure it out by FOILing. So -10, I've got a -6i, I've got a positive 15i, and then I've got a positive 9i squared. But that's going to be, okay, so here's the tricky part, -9. So now I have a -19 plus 9i. Please put the real part first and then the imaginary part, because that'll just make it easier for you and everybody else reading your work. So we probably weren't expecting that, -19 plus 9i, but let's hope for the best. Now, what's 25 and -19? 6 plus 9i. Okay, so now I have to go and multiply 2 minus 3i times 6 plus 9i. Okay, and I'm back to FOILing. I get 12 plus 18i minus 18i minus 27i squared. You can't see it, but that minus 27i squared, there it is. Okay, so that's going to become 12. Those are canceling out, And then this is going to become plus 27, which that is going to be 39, and we're pretty happy about that. Now we knew it had to come out to be 0 because of the complex conjugate 0 theorem. Okay? If 2 minus, oh no, we're not, we're not to that part yet, sorry. We know it's a 0 because they told us it was a 0. Okay, now we're going to do what I was just talking about. If 2 minus 3i is a 0, then the complex conjugate theorem says 2 plus 3i, so 2 plus 3i is also a 0. So now don't go back to the original. Start with this stuff you have and just divide. So bring down the 1. You're going to have 2 plus 3i. Those are going to cancel, so you're going to get negative 3. Now you do have to multiply negative 3 times this, but that's going to be negative 6 minus 9i. Whoa, that's what we thought was going to happen. You got a 0, right? Like the negative 6's cancel and the 9i and negative 9i cancel. Okay, so that's supposed to happen. Now this is interesting, and it doesn't usually happen, but we only have 2 numbers here. Remember, we started out with x cubed. So this became x squared. This is now just x. So x minus 3, we want to know when that equals 0, so x equals 3. I was trying to make it a little bit easier for you. Now, what do the directions say? Find all the zeros. So what are all the zeros? It was 2 plus, it was 2 minus. It was 2 minus 3i, that's the one they gave us. Then it was 2 plus 3i, we knew that because of the complex conjugate theorem. And then this last one right here was 3. And you can put them in any order, I don't really care. Okay, there you go.